But without further ado, I think we're almost right on time, a minute early even, so I won't linger. I'd like to introduce you to Matt Payne, CEO with AI, who's going to talk about context windows and why IA matters in LLMs and RAG.
Awesome. Thanks, Bob. I will take that extra minute that you've given me. I will definitely need it. Let me pull up my screen. Awesome. You guys should all be able to see that. Like Bob mentioned, today we're going to dive into context windows in terms of large language models and why information architecture matters and kind of how do these two things fit together, how to think about these two things independently and of course together. I'm going to try to keep this hopefully to about 35 minutes so we have time for questions. We'll see how I do. I do like to ramble, so we will see how that goes. So who am I? I run a company called With AI. We focus on AI consulting and development, primarily NLP and computer vision related applications. As you can imagine nowadays, that is a lot of generative AI. It didn't always used to be like that, but nowadays that is quite a bit of it. You can see, customers, usually either enterprise or early stage startups, trying to get stuff off the ground, get their product moving and everything like that. I was an ML engineer at Capital One, as you can see there. I did work there for a little bit of time, and that was kind of where it kicked off going into With AI. So we'll start with some of the basics here. What is a prompt-based large language model? I'm sure you've seen quite a bit of it on LinkedIn and stuff like that. I've tried to break it down into kind of three main pieces to think about, around this side. So you have the actual large language model itself. This is a model that has a lot of training data. It's trained on a lot of data in an offline task. So this is something that is done not during real time. That information used during training is not available in real time. That's why sometimes you see these models say, trained up to this date or something like that. If you've seen any of those data sets, they're large. People talk about using the whole internet or the whole Wikipedia or different stuff like that. But that's kind of what the basis is here in terms of the large language model side. What is a prompt? So a prompt is the piece where you actually provide information to use in this sort of workflow of interacting with this model. I noted here that OpenAI splits this into a system prompt and a user prompt. That is not the case, sort of across the board. There are plenty of models out there that just use one single prompt or different variations like that. But I did note here for anyone that's kind of familiar with that, this is split into two different things. This is where your instructions are going to go, your output's going to be generated, all the stuff that sort of entails interacting with large language models will be dealt with through the prompt. And then I noted here, sort of the third one is parameters. We are not going to dive deep into, parameters and how they work and stuff. I said it's just, fun math stuff for anyone out there that enjoys that stuff. Parameters are kind of what helps guide the model towards the output that you are looking to generate. They allow you to sort of add variability and different things like that to the equation to get that actual output you see at the end of the day. Couple of these that I'm sure you might be familiar with if you've played in this space. There's a bunch of ones, of course, ChatGPT being the largest, ChatGPT, GPT-4, all the different options that they have there, as well as Meta has their own model. There's an open source model called Mistral. I think, Google just, rolled out the Gemini. They had an update, I think, like a week ago. Whole bunch of different options. They are all considered prompt-based large language models. Quickly, I want to cover what RAG is. It's not something that we're going to go particularly deep into in terms of the way it works at a deep level, but I wanted to cover it just so that information is relevant down the road. RAG really focuses on you providing information in your prompt to interact with the language model, some sort of lookup to a knowledge base. This could be you manually, going to Google and grabbing information from a website and putting it in a prompt, or an actual sort of algorithm does it for you. All to kind of lay out generating something that is guided by that information. So if you were, doing a whole bunch of different stuff and you wanted to provide sort of, real-time information, that's really what it looks like there, to sort of guide to a specific result. So kind of wanted to lay that out so that everyone's on the same page about it. Like I said, we won't go super deep into it. There's kind of three key ideas to think about with prompt-based large language models, that really go into how do you build one of these, how do you interact correctly with this model, how do you really lay out this equation in a way that makes sense. The first one being instructions. So what are you actually trying to do, right? This is anything from summarize this book to, generate an email subject line, or write a legal document. What are the actual instructions that you are trying to do in this specific workflow? I feel like everyone's going to be familiar with that. If you're interacting with a language model and not using instructions, I quite honestly don't know what you're doing. But sort of that's one of the key ones to think about there out of the gate. Goal state output definition. This is a term that we use quite a bit when we talk about writing prompts and building prompts and doing stuff like that. It really focuses on defining for the model what is a good output. So an example would be, summarize this legal document would be the instructions in a list of 5 items or less. That would be sort of defining, hey, for this use case, what I'm trying to do, what do I actually want to get out? What is correct for me? And kind of guiding the model towards that. You will see that a lot. They often sort of wind together with instructions just due to the way that people write stuff. But it's something to think about, and a key idea to think about when you are interacting with these models, that you really want to define what is the correct result for me. Sometimes that's simple, sometimes it's not, but it is a key idea there to think about. The last one, which is the one that we are going to dive into the most, is, it's more of a key idea than it is something that is definitively outlined. But, the model's understanding of the context or information that's provided and how to use that information to complete the task outlined by the above. So does the model understand, with the context or information that's provided, how to use it? And you'll see, as we kind of go through, there's a lot of examples of the model doesn't understand how to use the context. It doesn't understand to use the information, normally due to, poorly structured data or stuff like that. But it's a very sort of key idea that, we think about quite a bit when we say, what's going on here? Why are we getting something wrong? Why are we getting something right? The model's understanding of how to use what I'm providing is a huge part of that sort of ability to understand, how to interact with these workflows properly. So what is context? Context is simply relevant information that's provided to the prompt that helps this workflow understand completing this task. I know we mentioned that before. As you can see in that graphic we saw above, it's provided there in the prompt. It's generally task or domain specific. It's generally something that's specific to our business or something like that the model isn't trained on. That's kind of a key point there, is it's not always something that the model already knows. And the way to think about it, as we kind of start to tie this together, is the same way that we think of human memory. I mean, if I asked somebody in the audience, hey, here's a calculus 1 math exam, use your underlying knowledge to do this exam, I think we would all probably not do super great. But if I provided you that same exam and then said, hey, here's a cheat sheet, here's some examples, here's some, other information that you can use at runtime actually doing the task, you would probably do much better. This is the same way to think about context. And as we'll see when we kind of go through that, I'm going to try to structure as sort of that human memory equation, because it really is something you can think about like that. It really is kind of to the model a similar format that is used to sway our decisions as we kind of go through the task. I mean, I think that was a pretty good example of that. I wanted to note quickly that all of these language models have different context windows and context sizes. It is not a one size fit all. You cannot just give this model everything you know in the prompt and say, do your thing. That's not really how it works. This is an example from, I think, GPT 3.5, where they have a context window of 16,000 tokens. Some other models have 4,000, 100,000. But it is good to note that, similar to a human, you have a limit to how much real-time context you can take at once. Different models differ, in different levels to that. But that is something to take into account when you're looking at context and context windows and putting these workflows together. So I wanted to start to tie this to information architecture. And I think this is probably one of the best ways to do it. We'll see what people think about it. This is a graphic from HubSpot that sort of breaks down kind of the three ideas that go into information architecture. You have your users, your context, your content, kind of all blending together to create how we think of information architecture, how we design for information architecture and different stuff like that. And I created my nice, my own version of it. Please don't make fun of my graphic skills. Of this same one, users, content, context, and how all of these still apply to these LLM based or RAG based workflows. You have your users, from the slide before, who is the user and what are they looking for? Just like that, we have a user running an application or model or using a prompt. Context, from the slide before, environment where the users engage with content. And we have that same thing. We have a prompt, we have a context window, and then of course we have that model underneath. And then I'd say the one that we see the most, overlap with is content. From the slide before, the information the user engages with, instructions, output, text content, prompt rules, examples. We have all these same pieces when correctly interacting with these language models that we see outline good information architecture before. I found that really interesting to sort of look at. We have all these same pieces, and you'll see as we go through, they do kind of combine together in a similar workflow. So I want to dive into some examples that I think do a really good job of showing what context is and how it actually fits with what we want to do. So here's a prompt I wrote. Write an email subject line for a marketing email for a women's clothing brand that's selling a blue dress. Pretty straightforward. I'll put on my hat and pretend that this is what I do. And you can see it generated a result that I think is fine. I think it's generic. I don't really think it, anyone out there that loves marketing, I don't really think it would do that well. And the key thing to note here is we haven't actually provided any context for this instruction. We didn't give the model, what our product looks like, or what the title is, or how do I like my email subject lines to write. We didn't provide any of this information, and so we got a bad result. This is the same idea that you would have if I asked you to write an email subject line, right? If I said, hey, I want you to do the same exact thing, and I didn't provide you, whose product is it? What does it look like? How do you like your results to look? I would probably write something poorly as well. And so you can really kind of think about it, when you're looking at this and saying, hey, my result's not good, how do I fix it? That, we haven't guided the model towards what a good result is. There's no personalization, there's no information. It really is just trying to really do its best based on what's provided. Now here's another one, and I wish I would have zoomed in on this a little bit. This is a follow-up to the one before for those that maybe can't see it. Same instructions. We're still writing an email subject line for a marketing email for a women's clothing brand selling blue dress. But this time we provided a whole bunch of context for the model to use. We provided specific product information. We provided a title. We provided a description. We also provided some relevant information to what a good email subject line looks like for us. You can see there's some list items, urgency in the email, structuring an offer, like just marketing email stuff. But I've started to tell the model, hey, this is what I think leads to a good email. And I've provided that context. And at the bottom, I've even provided an example of what a good email subject line looks like. I'm literally telling the model, hey, this is what I think a good one looks like. And the result we get is much better. I believe so. I believe this is a much better, email subject line. We can see a little bit of personalization. He even threw in an emoji. I didn't even ask for that. But we can see that, we provided some relevant information. We gave it, I think the bare minimum in terms of, hey, here's what the product, looks like in a text form. We provided some examples and we got a much better result. I think that would be similar to if you wrote the email as well and I provided this information, you would get a much better result. Wanted to dive into one specific part of that, which is the examples there at the bottom. So if you saw, I provided, an example there. This is one of the best sort of context pieces you can provide a model, is real examples of how to complete the task. Generally, they are relevant to sort of that specific task. I mean, I don't, if I asked you to do something and I gave you examples and they weren't related to it, that probably wouldn't be very useful. Similar idea here with the model. So I wanted to sort of call out and point out that this context is really valuable towards guiding the model towards a correct result. You're literally showing it how to complete similar tasks. And, the model is, of course, going to really like that and return much better results. So wanted to sort of show another one here. Similar use case, but, this is an example of context where I think context is just required. Not that task before you could generate a result without providing context. It might not have been good, but there are some tasks where they just require an actual document, an actual email, like an actual blog based on what the task is. So we can see this one here. I'm summarizing a legal document into a list of, key points. You're going to see some tasks just by the nature of what they are, where it's less about helpful context and more of required information. So some things like, instructions, rules, and examples aren't required, but other ones are. Wanted to sort of show that difference between the different context types. So now we're starting to get ready to really talk about how information architecture and context sort of merge together. So how do they think? So they, like I mentioned, they think similar to us. Text that's presented, properly, grammatically correct, in an easy readable format is easier for the model to understand. And I provided actual research references to this idea. This is not something that is just sort of, oh, I've seen it here or there. These models are trained on data that is written by humans. Of course, they prefer text that reads similar. I noted here probably one of the most common tasks that we do just generally as a company is just restructuring the information of what people are providing these models into a format that just makes more sense. Sometimes it really is that easy. People will say, hey, my model's not doing good. It's not performing well. How can I fix it? And it really is just, hey, the model doesn't really understand your data for a bunch of different reasons. And it sometimes is that simple. And we'll kind of see, as you might be starting to see, this is going to gear up towards information architecture. But, just wanted to kind of point that out, that really is the case of how these models look at the information we provide. So diving a little bit further into these examples showing how information architecture and context combine. This is a use case I put together. I web scraped our homepage and down into a sort of HTML document style. Wanted to point out here that, really easy task, don't really need to talk about it, but did web scrape this data down. And we are going to be using the Open Llama model. Wanted to spice it up here a little bit, play with a different model, and want to sort of see what we could do with this data that, although structured into an HTML format, isn't super readable to somebody unless they really understand HTML. And we'll see how the model, sort of adjusts to that. But sort of did that first task, spun up Open Llama. And then here's the use case. I provided that data, I provided that web scrape data to the model, and I said, hey, what does this business do? And it spit out, for the people that can't see, we are a team of data scientists and engineers who help businesses make sense of their data. And then it said, we help, and it actually didn't finish that sentence. If you asked me if that's what we do, I would probably say no. I think that's a little bit of a vague answer, I guess, especially based on what we have on our website. I don't think data scientist is ever mentioned on our website, and I certainly wouldn't say make sense of their data. Like, people, what does that mean? What this tells me is I've provided this HTML data. The model doesn't really get it. It can't figure out how to pull through this context that is pretty unstructured and sort of extract this information and really know what we do. It's generalizing a little bit to something that for itself is much easier to understand. So what I did next was I processed this data down a little bit. I removed JavaScript and some of the HTML tags that just are never relevant. I pulled it down to what I would say is a little bit of a nicer format. It's not perfect. I can still see there's some meta characters and stuff like that throughout, but it definitely reads better from there. If I asked a person who maybe isn't familiar with HTML to read that first one versus this one, they would probably say that this one's a little bit easier to read. So again, I asked, what does the business above do? And this time, we actually get a better result. For those that can't see, the business above is a company that provides services to other companies. The services provided are, and then it listed, these are just ones I know are exactly on our website. Made a nice little list of those. This is a result that if I saw, I would say is pretty good. I would say, yeah, that's probably what we do. So we can see we have cleaned up the text into a much more human readable information or sort of format, and we get a better result. We can kind of see that relationship. It's not perfect, but we're definitely getting there. Then what I did was I built a pre-processing algorithm again that focuses on taking HTML text and putting it into a list style format. So, really no HTML characters, none of that sort of stuff, no tags, just sort of a list style format with key value pairs, sort of saying like, this is a subtitle, this is a title, this is a feature card text, much more readable. I think if you went to a non-HTML understanding person, said this is what HTML looks like, they'd probably say this looks pretty good. Broke it down a little bit further and then reran it again, and the results are, I would say, better. They're definitely better, maybe not incredibly, but you can sort of see as we have improved that format that the results got even better. For people that can't see, the business above is a company called With AI. That's the first time it's actually mentioned us, that provides services to other companies looking to implement AI in an MVP or production build. Services provided are, and it lists them down. I think that is a much better outline. It takes into all of the things that I know we have on our site, where we have sort of a high level, what we do. We talk about the different type of engagements. It even mentioned development and strategy, which I know is throughout there. This is a really good result. And we can see that correlation between these two. As our text got much more readable, our results got much better. Want to dive into another use case here that I think shows some of the same stuff, but maybe in a different format. So one of the things mentioned there in those research papers is that tabular data, and especially very unstructured and messy tabular data, is one of the use cases that these models struggle with the most. As you can imagine, exporting Excel as a CSV and then pasting it into a prompt, not easy to read for me, not easy for a model to read. You kind of have your columns up top, your values are down below. You have to correlate the values to the columns all the way up at the top. Not super easy to read, and these models clearly have an issue with it. So what we have here is some product data. This is just a master SKU list from some sort of manufacturer. I'm not going to go into the details of it. It's just sort of a list here of products. This time we're going to use GPT. We're using GPT, OpenAI on the back end here. I asked it, hey, for this specific product, what is the manufacturer code? And it generates a result, and the result is actually wrong. This is actually, if we went back, the EAN code, not the manufacturer code. And I sort of highlighted down there in red, this is what it should have been. It actually gets the wrong value. We can see sort of a lack of understanding of how to correlate those categories above to some of the data that exists down below. This is a perfect example of, hey, we have tabular data. The model's confident. It didn't say, hey, I don't know. It gave a result. It's wrong. But we can kind of see like, hey, this result should have been answered, able to answer. I think I could have answered this by going through the CSV. Model gets it wrong. Just showing there, zooming in. That's what it should have been. That's the result we got back. Clearly not correct. So then what I did was I wrote another pre-processing algorithm to take CSVs and put them into more of a list style format. So it goes product by product and lists for each of the fields, key value pairs of, you can see manufacturer product code, country of origin, G10, description, goes all the way down for every single product that's in there into a much more sort of, I believe, readable format for the model. And we can see same question, what is the manufacturer code for this specific product? And this time it gets it right. No issues with it. I expected it to get this right. This to me is a clearly readable, information set. But we can see very easy. We clean up the data in more of a human readable format, and we get a result that makes sense. I wanted to show that again. The last sort of, use case I wanted to showcase here related to sort of how we structure our prompt information in context is a use case that is popular if you're doing RAG and stuff like that. This is normally query generation or search query generation or SQL query generation, taking some sort of natural language input, generating a new representation of that, using that in a lookup algorithm to grab data, and then responding with context. This is the same workflow we saw above with RAG, but we have a model there that is used to actually generate that search query. So we can see this is an example of one that I built before. The schema needs to be defined for this type of work. Imagine trying to write a SQL query when you don't even know what the schema looks like. Even if you do, imagine if the schema is messy. Imagine if you just have these huge like unstructured columns where it's just full of junk. There's no real structure to it. It's hard. I mean, you'd have to write some pretty complex queries. The model feels the same about this. This is no different for some sort of LLM. It's not a black box. It's going to understand what you're doing there. In this instance, we're generating queries for a pandas data frame. I provided, here are the columns, here's what you have, here's the first row of data. I even gave it an example, and it does a good job. It actually generates a pretty complex query pretty routinely. But the defining of our data and the fact that our data is easier to understand makes it much of an easier operation. This is something that, RAG workflows do every day, all the time. Some of those chatbots that you've used, they probably process 100,000 of these a day. This is a huge part of that workflow, and it's something where if your data isn't defined in a format that makes sense, can be a serious roadblock for something that is really required for some of these workflows. So what does this show? So it shows that when information is structured and presented to the model in a format that is easy to understand, that's the key, the results you get are just better. I mean, they just simply are. When the information is easier for you and I to read and understand and put together, you get better results with these models. So that kind of gives us two main ideas around, information architecture and interacting with context and large language models. Good information architecture and good prompt structuring are the same. When your model understands what you're trying to do, due to the schema making sense, your results are better. And it starts with your database and how you structure your data in there. Your prompt structure is generally going to look very similar to the way that you've defined your schema in your database, especially if you're doing lookup and stuff like that. And so when those two are aligned and when they make sense and when you've defined, your columns and everything like that, well, you lead to better results. It's just the end of the game there. It's really how simple that is. The other one is good information architecture leads to easier querying of database for this context. So when your information in the database, when your schema and your structure makes sense, when it's structured properly, you don't have a bunch of messy values, you don't have a ton of nulls, you don't have columns that are just essentially a combination of 50 other columns. Your querying, your ability to do that, to pull in context, becomes much easier. If your schema is just easier to interact with, as you can imagine, generating queries for that schema are easier. Both of these sort of LLM use cases both need information architecture on that side to be able to be useful and done effectively, no matter which model you're using. We saw Llama, which is considered a smaller model. We saw, OpenAI, similar idea there. And so we showed some prompts here. They were simple. One of the questions I sort of thought we'd get is, well, what about those, wildly complex prompts you see on LinkedIn? I'm sure you always see those graphics, people post them, it's got all that stuff. What about those? Like, aren't those fine? Can't those get past it? Why didn't you use one of those? All of those prompts are sort of focused on understanding the context provided. All of them focus on that. They all focus on trying to improve the model's understanding of information provided. And whether that's generating something new, whether that's breaking something apart, whatever that is, they are all focused on a better understanding of information, either provided as an input from the user or provided through context. This is an example, chain of thought, probably one of the most popular, more complex frameworks. One of the first things it does is it generates reasoning before responding. It makes sense of the data that's provided and then responds. Very easy to see there. React, another very popular framework, probably my favorite framework. The first thing it does is it generates a thought bubble. It thinks about what it's supposed to do based on the information it's provided. It thinks about how to make the most sense and fully understand what the task is. In that specific use case, they do searches, they do lookups, they do query generations, all in the same prompt. You have to think about what you're going to do and make sense of the context that's provided. And then Pearl, another one that's sort of, very focused on, let's generate a plan. Let's generate the information. What do we want to do based on the question that's provided? All of these are focused on gaining the most understanding from the model, or helping the model have the most understanding. And, regardless of if you're using one of these, deeper sort of prompt frameworks or something that's simpler, all of it's related to, can I make my information relevant to the model? Information architecture and having that stuff in place makes that much easier, no matter if you're using this, complex one or not. So, wanted to kind of pull those two together here at the end. I held out on showing these examples out of the gate because I think they might have, kind of been like the end. We could have said, okay, well, real prompting frameworks, they need the same stuff done. I wanted to show these at the end that even those that you see on LinkedIn, you see people walk around with, they are all focused on the same stuff. Bottom line takeaways, no matter the AI use case you're looking to develop, if you're using an LLM or some sort of workflow like that, information architecture matters for all the stuff that we've sort of seen there, the context and the prompts, the database structure, all the things like that. LLMs handle context just like you do. Examples, rules, clear instructions, all the stuff like that matters. They all matter when you're putting these workflows together. These are not black boxes that just understand how to do your stuff. And then the final point is, of course, information architecture and LLMs are two sort of separate worlds that are very much alike, and they very much play together. Someone who went from the LLM space to the information architecture space, not the other way around, I was very surprised at how much the way I think about interacting with LLMs is actually the same way that people think about information architecture. I was very surprised to sort of see that and put those two things together. And it really helped make sense a little bit more of what I should be doing, when building these workflows and stuff like that. That's all I got, guys.
All right, and wonderful. Thank you, Matt, for that presentation. And I'm sure it may have spurred some questions or thoughts. We definitely are open to Q&A
Yeah.
along the way. So if anybody has a question, feel free to pop it into the Q&A tool, and we'll make sure we route it over to Matt. But with that, I guess I'll throw one at you, Matt. So yeah, you mentioned in there, I was kind of curious to see that the structured data is hard for the LLMs to digest, but it also has a lot of kind of rich connections that it needs in order to understand the world. And like the knowledge graphs, it sounded like that's a good thing to build, but it might still be hard for the LLM to digest it. Maybe you could speak more to kind of what, kind of that formal relationship building and object models and knowledge graph building. And then, once you have something like that, how do
Yeah.
you leverage it?
Yeah. So I think that, I am, of course, coming from the AI world, a fan of your data making sense, your data being structured, whether that's a knowledge graph, a database, whatever that is. I think that, what you should think about is, these models are for the most part trained heavily on language style, natural language style inputs. And so, if you have your information in a knowledge graph or something like that, and it's structured well, don't think that you haven't done the hard part. That is the hard part. Putting it in some sort of, sentence style or list style format is much easier than, hopefully I didn't make it seem like it was hard or something. But it's one of those things that I try to say, you have done the hard part by structuring that info in a knowledge graph or something like that. Just make sure that the format is something that these models are used to seeing, and that is, for the most part, natural language style information. It's just something that, some models are going to be better at it than others when you provide like a CSV or something like that. But it is something to think about when you go from that world of, hey, my information is really structured. Like, I really like the way it looks in this database, to, hey, why isn't this export I just pasted in a chat GPT working well? And that really is the solution to it, is making it something that is much more human-like and readable in sort of just a text blob format.
All right, very good. Thank you for fielding that one. And I guess
Yeah.
if, yeah, if there's new questions that emerge, feel free to
Like
pop
we
them.
have one from,
Okay.
we've got two here from the audience. Do you know about the My GPT function in ChatGPT? Are you using it to tailor your GPT to better understand the context of your background more deeply? If yes, what does your configuration look like, and have you made any improvements?
Yes. Yes, that is a good question. So if you're familiar with, assistants or my GPT or stuff like that, that is a RAG style workflow, just like what I laid out there. And, you know, similar concepts from this apply to that. That is just another essentially, managed service way to do this RAG workflow. And a lot of those same principles of, hey, when the model pulls my context from that knowledge base that OpenAI provides, does it make sense? Is it in a format that makes sense? It even matters a little bit more with assistants or my OpenAI or stuff like that, because you actually don't control the lookup algorithm. They have a base embedding model lookup. You can't adjust that model to say, actually look through my data like this, or actually pull my data in like that. And so I actually think that the structure matters a little bit more when you're doing something like that, because you just don't have control over the actual lookup piece that could solve some of the woes around, oh, my data isn't structured that great in this assistance database. It's something just you have to think about even a little bit more, in my opinion.
Thank you. And then one more question that I have, at least, is it possible to provide too much context for the models?
Yes. So one, you'll see I noted in there that some of these models just have a hard stop on the amount of context. They provide a token limit. A token is roughly 3/4 of a word. So they actually have a limit to how many words you can provide. Now, the other research paper I linked in there, maybe I should have pulled some info out on that, sort of showed that if you provide too much context, usually if you are touching the top of that context window, the model actually generalizes its results much more because it can't actually parse out the specific information in your context that is relevant to your answer. So you absolutely can. A lot of people's issues, when we look at more of the lookup side, is that they're just pulling too much context in and the model just cannot parse through it. If you are doing some sort of RAG style pull information and your results are generic, like we saw in that first email subject line, if they're generic, but you're providing context, that usually means that the model can't figure out how to parse through your information, whether because it's not relevant or it's too much, to find what it needs to answer the query. That's a really good question.
Great. Well, thank you, Matt. I think we'll wrap it up there with a couple minutes spare, and give just a second for people to take a quick break and Andrew to get ready for our keynote with Andrew Hinton coming up at 2 o'clock.
Yeah.